Good morning, everybody. How we doing? Is everybody happy? Here I am. How you doing? Got my Superman shirt on today. Who's here? We got six people. Chloe, thank you. Very nice. Nicole's here. Well, there's people watching. Maybe there's just some creepos. Who else is here? Two people. Hunter's here. Okay. Well, there's still more people watching. Ryan's here. Well, here, let's while people are checking in. Here's the plan. I got information. It looks like for those of you that are here, it looks like for seniors, that's you guys, your last day of school for seniors is going to be the 13th, which is good for us. It's the day after our AP test. So we'll take the AP test on the 12th. We'll all get back here on the 13th and see how things are going. I don't think we're going to do any senior picnic or senior brunch or anything like that. In fact, I've heard, not official, but the governor is going to come out and say this is the way it's going to be for the rest of the school year. So that's what I heard. We'll see how that goes. But probably this is going to be the way it's going to be. So don't forget to take attendance today. Make sure you check in and talk to your friends in class. It was doing well, and then people are trailing off. We got people that aren't showing up, people that I'm not getting information back, people who aren't checking in. So I'm going to send a little message to everybody, but you have to. This is the most important thing. Like I said in the comments in the update today, it's on you. Okay, you were taking the AB test, and if you're don't slack off. This is the way college is going to be, guys. College is going to be like that. It's going to be. Let's say you got a 3-credit class. You're only going to be in class for like 2.5 hours, 3 hours a week. So there's going to be a lot of outside time. Now you will be able to meet with your friends instead of meet online with your friends, but you make sure you're all working on this. Don't fall. It's been already we had 2 weeks for spring break, and now we have 3 weeks of e-learning, and it started strong, but it's kind of slowly trickling down. So don't forget to take attendance, but that's not working. Taking attendance is not working. Make sure you come here. Make sure you keep reviewing the AP problems. And we're going to go over a couple more sections next week. I'll put some more problems out. For example, the assignment, you have to turn in this week these 3 problems. Now, whether you could do it on Schoology, you could do it, email me your work. I'm going to try to put a submission on Schoology. So you could do it on AP Central. You could submit it on AP Central. So this is, hold on, I've lost that problem that I was going to do for Eric. This is, 1 second. Lost my problem. Hold on. Where was it? All right. So what I was saying is you could submit these 3 assignments, the problem sets. You could submit it on AP Central if you're doing it on AP Central to practice. And next week we'll go through a little practice of how to do it. You could do it on just PDF and email to me. Or I'm going to try to put a submission button here on Schoology. I'm going to work on that today as I'm teaching my kids on reading, and we're doing numbers. We're doing counting coins and dollar bills. And so it's like 38 cents. What's the most efficient way to make 38 cents? That's what we're doing for us. So call your friends, talk to them. There's people that aren't showing up that I haven't seen. And it's who cares about your grade? It's you're taking the AP test, and you're going to do poorly on that AP test if you're not keeping up with what we're doing. And maybe we'll work on some integrals, and because I think one of your questions is really going to be one of those bathtub type problems. We'll work on some integrals next week. Okay? But there's a few questions I want to talk about. Take a look. Here's the first one. This is what a couple people are asking about. Then we'll open it up for anybody on now that want to talk about stuff. And so if that's as far as you got, those people who listen later, you got to keep participating. You got to start working through on this. So I'm going to do grades, and then whoever's not participating, we got to talk to them. Here was the question. This was 5.4, number 5. A couple people emailed me about this question. So let's talk about this one right here. Okay, so notice what we got. We got a picture. And we got the areas. Areas, not integrals. We got the areas. And it's just telling you there's horizontal tangents. So it's max and mins. Determine the absolute, this is question number 5. Determine the absolute minimum value between 0 and 9. I have 0 and 8. 0 and 8. We want to find the absolute minimum value between 0 and 8. Okay? Now remember what they gave you, though. They didn't give you the function, f. They gave you the derivative. Okay? But that's okay, because if they have the derivative, let's go to our documents here. If you have the derivative, remember, how do you find an absolute minimum? Okay, a minimum occurs for step 1. You take the first derivative, and you set it equal to 0. Well, they gave us the graph of the first derivative. Okay, the graph of the first derivative has a 0. Okay, so we make our number line, and we check. Oh, it had equal sign, so the minimums could occur at 0 or at 8 also. And where's the first root of equal to 0? At 1. And then it crosses again. It says it crosses the axis. It crosses again at 1, 2, 3, 4. And then it crosses the axis at 6. And then it's back to the endpoint. Okay, so now let's check this. We'll do first derivative test. We're talking about first derivative test here. And it's positive right there. Positive right there. Between 4 and 6, it's negative. And then it's positive again. Okay, and we had a nice little trick. If we're doing first derivative test, we go like this. We go up, up, down, up. Okay, and then so the possible minimums, or actual relative minimums, there's a relative minimum at 0 and a relative minimum at 6. Okay, so we say relative mins at x equals 0 and at x equals 6. Now, if you have to justify that, let's just practice that justification. 0 is a relative minimum since it's an endpoint and the derivative is positive after. Okay, since it's an endpoint and f prime of x is positive after. Squeeze that in there, after. 6 is a minimum. Okay, 6 because the first derivative is equal to 0, and it changes. Remember, we talk about your binder should be right in front of you. Speaking of that, if the last day of school, I just thought of that, a couple people borrowed books. Okay, like I think IO has like 5 books. A couple people borrowed books. We're going to have to get those back. So the school is going to work on something to return. If you checked out a calculator, if you have one of my calculators, and just to return stuff to me. And we'll see how, I don't know how that's going to be or how people are going to turn stuff in and things like that. F prime is 0. Okay, it changes from negative and x is less than 0 to f prime of x is greater than 0. That's how you find the minimum. Now, we're not done yet because it says find the absolute minimum. Okay? Determine the absolute minimum. That's what we're looking for here. Okay? So we're not finished with. So now, okay, we want to find the value. Okay? We want to find the absolute minimum value. Okay? So if we find the value of f of 0 and find the value of f of 6, whichever one's lower is the actual minimum value. You see? So if we have the derivative and we want the values, what do we got to do? Everybody should be saying you got to integrate right now. So to get f of 0 and f of 6, we have to integrate the derivative. And now we just got to pick the bounds. Remember, I always say set this up, set that up. And now we just have to pick what bounds we're going to use. Let's see. Did they give us anything? Oh, yeah. They gave us f of 8 equals 4. So if they give us f of 8, let's find f of 6 first. If they gave us f of 8 is equal to 4, I'm going to use this equation. If they gave us here, let's do it again. If they gave us, I'm going to use this equation. 0 to 8 of f prime of x dx is equal to f of 8 minus f of 0. You see how these equations have 0. Let me talk through it one more time. Remember, are you okay? And here's where you have to just speak up for yourself. Are you okay how to find the relative minimums? We did first derivative test. First derivative is equal to 0. We test regions. How do we find those values? We're given a graph. And here's your justification. This is a minimum since it's an endpoint and the first derivative is positive after. This is it's a critical point and the first derivative changes from negative to positive. So then we got to find the values. How do we find the values? If we have the derivative, we integrate to get the values. So we're going to work our way backwards. Okay, so when we integrate, we set up fundamental theorem. Now, how are we going to find the integral of, looks like known geometric? What's the integral from 6 to 9? Okay, let's look at the picture again. Here's the picture. The integral from 6 to 9 is right here. The integral from 6 to 9 is 7. You see that? So, we say 7 is equal to 4 minus f of 6. Well, that's pretty easy. We could find f of 6. F of 6 is negative 3. Now, what's the integral? Let's go back to the picture. What's the integral from 0? All right, be careful here. What are the things we've got to pay attention to? If it's below the x-axis, it's negative. The integral is negative. So 2 plus 6 is 8. Minus 3, we're at 5. Plus 7, we're at 12. Okay, or some people like just doing this. 2, 6, that's 15. And this is minus 3, it's 12. Do all the pluses first. But the integral from 0 to 6, so we have 12 is equal to 4 minus f of 0. And so therefore f of 0 is, slide that over, f of 0 is negative 8. So now answer the question, what is the absolute minimum? The absolute minimum is negative 8. That number is smaller than that number because these are the only possible minimums. F of 0 is equal to negative 8. F of 6 is equal to negative 3. So the smallest one is negative 8. F of 0 is equal to negative 8. There was number 5. No, number 4. Yeah, number 5. That's a good one. That's a good problem. How is that problem? Notice a lot of things we covered. Mins, maxes, absolute mins and maxes, fundamental theorem of calculus is a good problem to see on the AP test. It covers a lot of stuff. All right, that was, anybody else have, while you're here, who has another one that we should talk about? Okay, there's only, how many? 6 people watching right now, so be selfish. Say, this is the one I want to talk about. 3 on the same section, Eric? 5.4? Let's take a look at number 3. Oh, it's section 5.7. Okay, wait. 5.7? Hold on. Let's go back to that one. 5.7, number 3. Okay, wait, you said yes and no. I'm confused. Okay, section 5.4. number 3. This one right here. 5.4, number 3. Okay, so take a look at what we got. Find the value of x for which h is a minimum. Okay, we want to find a minimum here. Now notice what we have here. There's 2. So here's h of x. It says the graph. Oh, wait, this is for that one. Hold on. Okay, wait, so it's this picture. This picture is the graph of the differential equation is h of x is equal to this. So this is the graph of, this is the graph, they should have labeled it. I like when they better. The graph of the, so this is f. The graph of the differential equation f is it. So this graph right here is f, okay? And h of x is equal to the integral of that. So find the value for which h has a minimum. Okay, we want to find minimums and a closed interval. Okay, so like always, same argument, same plan, same process. We want to find a minimum. So if here's h of x is equal to, this is those of you have your sheet out at home, 5.4, number 3. H of x is a minimum. H of x is equal to 1x of f of t dt. There's your function. Just start with the function. Now, how do we find a minimum? To find a minimum, we take the derivative. Okay? H prime of x is equal to, what's the derivative of an integral? F of x. H prime of x is equal to f of x. Is that okay? That's guaranteed going to be on your test. Fundamental theorem. Guarantee is going to be there. So, set it equal to 0 to find the minimum. Now notice the information. Let's switch it over. The information was given in a graph. This is the graph of f of x, so this is the graph of h prime of x. You see, we just said f of x is equal to h prime of x. So if that's the graph of f of x, that's the graph of h prime of x. So, where is it equal to 0? It's equal to 0. Make our number line. Take a look. Oh, close from 1 to 7. It's equal to 0 at 5 and at 7. This is the graph of h prime of x. And remember, once you establish, here's just notation for the AP test. Once you establish, let's look at our paper. Once you establish that h prime, always say that. Just keep those associated together. So we look at our graph here, and before it's positive, after it's negative, and we'd have our little trick, up, down. So the minimum, 1 is a minimum, and 7 is a minimum. You see that? Same thing we were just talking about. 1's a minimum, and 7 is a minimum. Okay, so where does it have a minimum? So what's our justification? Okay, this graph has a minimum. So at x equals 1 is a minimum, since it's an endpoint and h prime of x, okay, which equals f of x, is positive after. You see, that's your justification. You say it's an endpoint and it's positive after. And then you say x equals 7 is also a minimum, okay, since it's an endpoint. And h prime of x, just associate these together, f of x, is negative before. So, which one is the absolute minimum? They're both minimums. Which one's the absolute minimum? Okay, so to find the absolute minimum, we have to find values. The problem is I wasn't given any initial condition. I wasn't given any values of h. Okay, so we just got to compare these two to each other. We want to integrate 1 to 7 of f of x dx. Okay? If we integrate from 1 to 7, okay, because we already know, since look at this, we already know if I plug 1 in there, h of 1 is 0. Right? If I plug 1 in there, h of 1 is 0. So all I got to do is see if this is positive or negative. If it's positive, Okay, h of 1 is 0. Remember, this is equal to, if this is let's just change this. Let's remember, 1 to 7 h prime of x dx. Remember, f of x is equal to h prime of x. So this is going to be h of 7, just to show fundamental theorem again. H of 1 is 0. So this integral is going to see what h of 7 is. If h of 7 is positive, if h of 7 is negative. Remember, we can't find the exact value, but we can find if it's positive or negative. So take a look at the area. Do you think the integral from 0 to 7 is positive or negative? Where is there more area? Is there more area above? Right here? Is there more area compared to that one? That looks like a lot more than that one. So the integral from 1 to 7 is positive. I cannot find the actual value, but I know it's positive. Okay, so if this integral is greater than 0, that means, if you keep it going, that means h of 7 minus h of 7 minus h of 1 is greater than 0. So that means, if I move this over, h of 1 is less than h of 7. You see, I just add that to both sides. H of 1 is less than h of 7, or you could just say h of 7 is positive. But I like this comparison right here. So which one's the absolute? The question is the absolute minimum. So that's the lower one. Even though I don't know what the value is, and notice the question didn't say find the actual value. I couldn't find the actual value. Okay? Find the value of x. I couldn't find the value of y. There's no way. It wasn't given any initial condition there. Who is that? Eric, you're asking about this. What do you think about that? You see how we found the minimum there, the two possible minimums, and then we compared them to each other with the integral to see which one is better. Okay, let me know what you think about that. We're going to go to 5.7, number 1 and 2. Hunter's asking about that. Okay, and remember what 5.7 is. Let's see what it says here. Let's go to the picture. All right, what we have here is we have a differential equation. It's number 1 here. We got a differential equation, and it's dy dx. Let me put it up here. Let's switch over. Dy dx is equal to 3 minus x over y, right? 3 minus x over y. And number 1 says you got to f is the solution, okay? Such that y equals negative 2 is tangent to the graph. Oh, what did they just say there? Y equals negative 2 is tangent to the graph. So they said, okay, translate that, y equals negative 2 is tangent. Okay, y equals negative 2 is tangent. They said when y equals negative 2, dy dx, they have the same slope. If it's tangent, remember tangent, they have the same slope. Well, what's the slope of y equals negative 2? Y equals negative 2 is a horizontal line. So they said that slope is 0. Everybody see that? Now they want you to find the x-coordinate of that point and determine whether it's a max, min, or neither. Okay, but first of all, did you translate that? That's the hard part of the problem. Did you translate that? They're giving you information right there. Okay, because now we can find the x easy. Take a look. We plug that in. 0 is equal to 3 minus x over negative 2. I'm going to cross multiply. 3 minus x is equal to 0. Pretty easy. X is equal to 3. So the point is 3 comma negative 2. Okay? Hunter said no. What do you mean? Like no? Like, there it goes. So here's what you got to get from that. As soon as they say tangent, something's tangent to the graph. You got to say to yourself, up, same slopes. Same slopes. And if you have a line, let's say the line was, y equals 4x plus 5. Oh, so at that point, the slope is 4. Well, here it says y equals negative 2. You got to recognize that as a horizontal line. Y equals negative 2, horizontal line. At that point, they have the same slope. So when y equals negative 2 right there, the slopes are the same. Well, what's the slope of y equals negative 2? 0. So we have that. Everybody who's paying attention, following along online, did that make sense? That is the hardest part of the problem, is translating that. Okay, because now we got to decide if it says min or max. Here comes the first derivative test and second derivative test. Okay, should we do the first derivative test or second derivative test? We know the derivative is equal to 0 at that point, so both of them are so far. Now the first derivative test, number line. And here comes the problem with first derivative test. We don't have a point to the left and to the right. First of all, 2, let's say to the left. 2 comma what? I don't know any value. 5 on this side, 5 comma what? Okay, tangent is always 0 for slope. Wait. For a horizontal line, tangent is 0. Okay, in this problem, look at the problem. They said the line y equals -2. Y equals -2 is a horizontal line. If they said at y equals 4x plus 5, then we know dy dx is equal to 4. You see, if they said the tangent line, maybe they say the tangent line at x equals 6 is 4x plus 5. Well, then I know x equals 6 and the slope is 4. This is just harder because people think they're just giving you a point, and they're not. They're giving you a tangent line. They say this line, look, it's right in front of it. The line, let me point to that. The line, right here, the line, y equals -2, is tangent to the graph. So as soon as they say line, you got to be thinking, what's the slope? So if they said, let's say they said at x equals 5, the line 4x plus 5 is tangent to it, then we know at x equals 5, the slope is 4. So Eric says tangent is always 0 for slope. No, tangent is not always 0 for slope. Tangent is always 0 for a horizontal line. And y equals -2 is a horizontal line. So then we were saying I got to use second derivative test right here. I got to do second derivative test because I don't have any points. I can't pick a point to the left and to the right because I don't have the function to plug it into. If I pick, let's say, if I say, I agree 0 is to the left, so when x is equal to 0, I don't know what y is. So I'm going to do second derivative test here, because second derivative test, I never have to move off the point. So let me take the second derivative. Be careful here. We got to do quotient rule. Low, d high, minus high, d low. Don't forget d low is dy dx. That part people always miss. All over bottom square. Got to use quotient rule there. Good review of quotient rule. Low d high minus high d low. Don't forget chain rule. There's always chain rule. So let's plug in the points. Oh, look. dy dx is equal to 0. X is equal to 3. Y is equal to -2. So, watch my notation. When at the point 3 comma -2 is 2 over 4 is 1/2 is greater than 0. So what does second derivative test tell me? The first derivative is equal to 0. The second derivative is positive. That's how you justify it. This must be a minimum at this point. How's that? Hunter asked about this one. What do you think? Did that make sense before we go on to number 2? I'll leave that right there. Could you do it after you figured out that tangent line little thing? All right, now number 2 says, we got a function, another function. We got, let me write it down, f of x is equal to k square root of x minus natural log of x, and x is greater than 0. Okay? It says find the value of k For what value of k does it have a critical point at x equals 1? So they're saying x equals 1. Now here comes another translation. A critical point. What does it mean to be a critical point? To be a critical point, the first derivative, we'll go f prime of x, the first derivative equals 0. That's what it means to have a critical point. So they're telling you the first root is excuse me. The first root is equal to 0. X is equal to 1. Find k. You see? So let's see what I got. F prime of x. Let's take the derivative. K is a constant. So this is x to the 1/2. So 1/2 k x to the negative 1/2. Just drop the power down, subtract 1 from it. What's the derivative of natural log? 1 over x. There's the derivative. The first derivative is equal to 0 because it's a critical point. 1/2, solving for k. X is 1 minus 1 over 1. Let's see what we got here. Well, 1 to the whatever is 1. So I add 1 to both. So this is negative 1. So 1 is equal to 1/2 k. K is equal to 2. You see that? When x is equal to 1, k is equal to 2. Does that make sense? Not done yet. Just finding the value for k. Okay, and now here's another one where we have to use second derivative test. I know when x is equal to 1, the slope is 0, k is equal to 2. Okay, so if you're thinking, well, I'm going to use first derivative test. We don't know what k is when x is 0. We don't know what k is when x is 2. You see? I got to use second derivative test here. I got to stick on this point because if I move off the point, everything changes. So I have my derivative when x is equal to 1. I have 2. I'll plug in 2, 1/2, 2, x to the negative 1/2 minus 1 over x. You see? There is k only when x is equal to 1, only when I plug in 1 right there. So I take the derivative, f double prime of x. Okay, that's 1. So negative 1/2, x to the negative 3/2 minus, and I'll make that x to the negative 1. So minus negative 1, x to the negative 2, just to do power roll on those. Remember, this only works when x is equal to 1. So I plug in 1 here. Let's see what I get. I plug in 1. I get negative 1/2, f double prime of 1. I get negative 1/2, and I get positive 1. I get a 1/2, which is positive. You see, I cannot move off this point. That's another thing you got to make sure when you're doing first derivative test, second derivative test. If you're doing first derivative test and that means you move off the point, everything changes. If you're doing second derivative test, you don't have to move off that point, so everything stays the same. So now, second derivative is positive. First derivative is equal to 0, was given. So this must be a minimum using second derivative test. Okay, who asked about that? Hunter, that was number 2. What do you think about that one? Everybody who's here right now, everybody feeling okay on these problems? How we look here? Okay. All right. So today, if you're stuck on something, hopefully you've been doing these all week, you have to submit them. You could email them to me. You could post it on AP Central. Or I'll try to put a button here so you could post it here on Schoology. Doesn't matter. Also, please talk to your classmates. I want to be talking to them also after I do grades and I see someone hasn't turned in anything. There's like 4 people that haven't turned in anything since the beginning. Okay, so we're going to do that also. Oh, Eric got one more. That's good. Make sure you get your questions asked. 5.4, number 10. Let's go to 5.4, number 10. Okay, so another one of those k's, another one of those constants right there. Okay, we got f of x. Let me enlarge this so I can see it here. Here, let's see if you can see. This is 5.4, number 10. We got f of x. 5.4, number 10. F of x is equal to x cubed minus 5x squared plus 3x plus k. Okay? And the question's asking, find the value for k, which this is a relative minimum. Okay? So what does it mean to be a relative minimum? Okay, we want to find the values of k for which f, there you go. Find the value for k for which f has 11 as its relative minimum. Okay, so let's see what we could do here. Okay, they're saying the relative minimum is 11. We don't know what x is yet, but they're saying the relative minimum is 11. That means when I plug in whatever that x is, I should get 11 right here. Okay, so find the value for k for which that is k. So let's first of all find the minimums. How do you find a minimum? You take the derivative. Notice when I take the derivative, plus 3, k goes away. We don't have to worry about k when we're taking the derivative. Relative minimum, we set the derivative equal to 0. X plus 3. All right, we got to do a little factoring here. 3x and x. How about 3 and 1, negative, negative? Double check that. 9 minus 10, or minus 1 is 10. That works out well. So possible, the critical points are at 1/3 and at 3. Let's make our number line. Label it 1/3 and 3. Everybody see what I did there? Okay, we took the derivative, set it equal to 0, solve for x. These are where possible values occur. Let's see what is each one of them. Okay, I'm going to use first derivative test here. Okay, I could do second derivative test also. This is, since we have the equation, second derivative test, first derivative test, maybe we'll show them both. First derivative test, I test the points to the left. Let's take 0. I plug in 0 here to the first derivative, and I get a positive number. Take 2. I plug in 2 here, I get a negative number. How did I know that so quickly? I'm using the factoring. I plug in 2 there, I get positive times a negative. I plug in 50. Positive, positive. So we go up, down, up. So since the arrows, since there's no endpoints, 3 is where the minimum is going to occur. There's first derivative test. Let's just show second derivative test. I take the derivative again. F double prime of x is equal to 6x minus 10. I plug in 1/3. When I plug in 1/3, I get negative. That must be a maximum. I plug in 3. I get positive. That must be a minimum. So this is our minimum. This is our maximum. Now the question is saying find the value for k, for which now we know 3 is the location of the minimum and the actual minimum is 11. Okay, so notice I could get right back to the problem here, and I could go here and I could go, all right, the actual minimum is 11. It happens when x is equal to 3. 3 times 3 plus k. You see? All we have to do is find k. I'm going to use my calculator since I'm being lazy. And we got 27 minus 5 times 9, 45, plus 3, plus 9 is negative 9. So we got 11 is equal to negative 9 plus k. K is equal to 20 right there. All right, let's go through this one more time. The question was, what did they tell us? It's about translating again. It told us the minimum occurs at 11. We don't know what x value that is, but we know the minimum happens at 11. Okay, so if the minimum happens at 11, let's find the minimum. How do we find the minimum? We take the derivative, set it equal to 0, find the critical points. Do second derivative test or first derivative test. Here in red is first derivative test. We test the regions, and we see that 3 is a minimum. You don't like that? There's second derivative test. Now you plug in 1/3, and you plug in 3. And shows it's a minimum also. There's a good review of first derivative test and second derivative test. So the minimum occurs when x is equal to 3. The minimum value is 11. I'm back to now I didn't plug it into my derivative. The minimum value is 11, so I plugged it into the original function. Plugged in 3 for x, 11 for the function. Easy to solve for k. Who asked this? Eric. Eric, what do you think? Is that okay? Now remember, if you're watching this later, you can always pause it and try something out and see if you could figure it out. It never said value, though. I'll find the value of k for which f has 11. Well, 11 as its relative minimum, that 11 is the value. Yeah, that's it doesn't say the actual value, but it's telling you what the minimum is. I said, what's the maximum height in the room? 6 feet 2 inches. That's didn't say value, but still, that's what they're looking for there. All right, so you have to turn in these 3 assignments. We'll have 3 more next week. Like I said, for seniors, the last day of school is the 13th. They already came out and they posted that. But probably, like Jimmy was saying, his dad was telling him, but probably I've been hearing from my friends in Springfield that probably they're going to do this. We're going to be doing this the rest of the year. So we'll keep doing this every week. We've got 3 more weeks. So we'll have more problem sets. We'll keep working on these problem sets. And you got to keep working on this. So here's where you can't slack off. You worked so hard for the last, 5, 6, 2, 10 years, whatever. You worked really hard. You're paying for the test. The test should be pretty good. You should open notes, open everything with calculator. But if you don't work on this the next few weeks, you're going to be rusty. And you only have an hour. Okay, so there's so much things to keep you going on this. So don't forget, this is where you have to have some personal desire to want to accomplish this. And I know you guys are here right now, so I'm preaching to the choir here. But when you talk to your friends, when you talk to your other friends, or when you're watching this online, you got to be motivated to do this. Okay? All right, everybody have a good day today. And don't forget to turn in these assignments. That'll be your grade. And if you haven't turned in last week's assignments, turn in last week's assignments. And if you haven't turned in the assignments from week 1, turn in the assignments from e-learning week 1. Okay? Keep working on this. Have a good day, everybody.